Think about this. A modern garage door can weigh more than 180 kilograms, move with the push of a button, survive thousands of opening cycles, and protect everything inside your home. Yet most people never stop to wonder how something so massive and precise comes to life. And this hidden journey begins long before a garage door ever reaches your driveway. Imagine walking into a factory where giant sheets of steel move like rivers, robotic arms dance with perfect timing, and sparks light up the air like fireworks. You hear the deep hum of machines, the hiss of compressed air, and the steady rhythm of conveyors carrying parts from one station to another. And this is where it gets truly extraordinary. What happens next surprised even experienced engineers. But here's what nobody tells you. A single insulated garage door contains layers of engineered steel, foam insulation, precision springs, rollers, hinges, and electronic systems that must work together flawlessly. Some components travel thousands of kilometers before finally meeting on the production line. Behind every smooth opening motion lies an incredible story of materials, heat, pressure, and human ingenuity. Most people never think about this, but millions of garage doors are produced every year, and every one of them must withstand wind, rain, dust, heat, and countless opening cycles. Engineers designed them to operate reliably for more than 20,000 movements. That's like opening and closing your garage every day for decades. And the journey starts with raw materials pulled from the earth itself. The backbone of most garage doors is galvanized steel. Much of this steel originates from iron, or mined in Australia, Brazil, and Canada. After refining, steel producers create coils with purity levels above 98%, and some coils weigh more than 20 tons. Trains, cargo ships, and trucks transport these giant rolls across thousands of kilometers before they finally reach the factory floor. For insulated garage doors, manufacturers rely on polyurethane foam chemicals derived from petroleum products. These materials often come from chemical facilities in the United States, Germany, South Korea, and China. Engineers carefully control the ingredients because even tiny changes can affect insulation performance. And this hidden layer will eventually help homeowners save energy without ever seeing what's inside. Meanwhile, aluminum for tracks and decorative components begins its own journey inside giant bauxite mines. Copper for electric motors comes from massive deposits in Chile and Peru. Zinc coatings protect steel from rust, while synthetic polymers become weather seals that keep water and dust outside. By the time these materials arrive at the factory, they have already traveled farther than many people will in their entire lives. And this is where the story becomes even more fascinating. Before a garage door can protect your home, these raw materials must pass through heat, pressure, lasers, robots, and some of the most advanced manufacturing systems on Earth. What happens inside the factory is something few people ever get to see. Inside the factory, everything begins with enormous coils of galvanized steel weighing up to 20 tons. Automated decoiling machines slowly unwind the metal at speeds approaching 30 meters per minute. You can hear the deep metallic rumble as the steel feeds into rollers with incredible precision. Most people never think about this, but even a tiny defect at this stage could affect the entire door. Next, massive forming rollers shape the flat steel into panel profiles. Some roller systems spin at over 300 revolutions per minute and process hundreds of panels every hour. Sparks occasionally flash as trimming systems remove excess material with millimeter precision. The air smells faintly of machine oil, and the sound of steel meeting steel echoes throughout the production hall. And this is where it gets truly extraordinary. Hydraulic presses apply forces exceeding hundreds of tons to emboss decorative patterns onto the panels. Within seconds, smooth sheets transform into beautifully textured surfaces that homeowners recognize instantly. What happens next surprised even experienced engineers, because appearance is only one part of the equation. For insulated doors, workers and automated systems inject polyurethane foam between steel layers. Chemical reactions create expanding foam that fills every cavity in just minutes. Temperatures inside the material can reach around 50 degrees Celsius or 122 degrees Fahrenheit. As the foam expands and hardens, you can almost imagine the heat radiating as the hidden core takes shape. After curing, computerized cutting stations trim every panel with astonishing accuracy. Laser-guided equipment measures dimensions within fractions of a millimeter. Conveyor belts carry components through the facility, while workers inspect surfaces under bright lights. The entire operation moves with the rhythm of a carefully choreographed performance. Meanwhile, another area of the factory produces the tracks, hinges, rollers, and brackets that will guide the door through thousands of cycles. Precision bending machines shape steel components with incredible consistency. Bearings are lubricated, hinges are assembled, and every moving part receives careful attention. Most people never see these hidden pieces, yet they determine how smoothly the entire system will perform. Perhaps the most powerful component of all is the torsion spring. Engineers manufacture these springs from high-strength steel wire designed to store enormous amounts of energy. Special winding equipment twists the material under carefully controlled tension. One properly engineered spring can help lift a door weighing more than many motorcycles. Finally, assembly crews and robotic systems bring everything together. Hinges, rollers, insulation panels, weather seals, and reinforcement structures combine into a finished product. The sounds of power tools, moving conveyors, and pneumatic systems fill the air. But here's what nobody tells you. Building the door is only half the challenge, because proving that it deserves your trust is an entirely different story. Once the garage door leaves the assembly line, an entirely new challenge begins. Engineers must prove that every panel, hinge, and spring can survive years of punishment. Most people never think about this, but manufacturers intentionally push their products to the point of failure. And this is where the hidden world of technology takes over. Robotic arms equipped with AI vision systems inspect surfaces for scratches, dents, and imperfections that the human eye might miss. High-resolution cameras capture thousands of images every second, while laser scanners measure dimensions with tolerances tighter than 0.5 millimeter. If even the smallest defect appears, the system immediately flags a component. What happens next surprised even experienced engineers. Specialized testing machines repeatedly open and close the doors thousands of times. Some premium models endure more than 20,000 operating cycles before engineers approve them for customers. The motors hum endlessly. Rollers glide along steel tracks, and sensors record every movement. The rhythmic sounds echo through the testing laboratory day and night. Wind resistance tests reveal another astonishing fact. Powerful fans simulate hurricane force conditions, while pressure chambers measure structural strength. Reinforced models can withstand winds exceeding 160 kilometers per hour. Imagine standing nearby and hearing the roar of artificial storms as engineers watch computer displays in real time. Manufacturers also perform impact tests, corrosion tests, and extreme temperature evaluations. Some chambers expose materials to freezing temperatures below -30 degrees Celsius, while others simulate scorching heat above 70 degrees Celsius. Sensors monitor every reaction to ensure the doors continue performing under harsh conditions. Rejection rates usually remain below 2%, thanks to strict quality standards. But here's something remarkable. Even in factories filled with robots and automation, skilled technicians still outperform machines in certain tasks. Experienced workers can detect subtle sounds, tiny vibrations, and unusual movements that sensors sometimes overlook. Human intuition, developed through decades of experience, remains one of the most valuable tools in the entire industry. International certifications such as ISO quality standards require manufacturers to maintain extraordinary consistency. Every measurement, material batch, and inspection result becomes part of a digital record. Computers track thousands of variables throughout production. And this is where it gets truly extraordinary, because the scale of this industry is far bigger than most people could imagine. Think about this. Every year, manufacturers around the world produce tens of millions of garage doors, generating a market worth well over $10 billion. That's an industry larger than many countries' entire economies. Most people drive past garage doors every day without realizing they represent one of the most advanced sectors in modern building technology. And the story behind that growth is truly extraordinary. Today, China leads global production, followed by the United States, Germany, Japan, and Canada. Together, these nations account for the majority of the world's garage door manufacturing output. Thousands of factories and suppliers support a massive network that employs hundreds of thousands of workers. From steel mills to electronics companies, entire industries depend on this hidden supply chain. But here's what nobody tells you. 50 years ago, many garage doors operated entirely by hand. Electric openers existed, but they lacked the sensors and safety systems that homeowners now take for granted. Over the decades, engineers introduced remote controls, rolling code security, insulation technology, and smart home connectivity. What once served as a simple barrier evolved into an intelligent machine. Did you know that some premium garage doors contain enough steel to equal the weight of a small car? And some commercial models stretch several meters wide and weigh more than 450 kilograms. What happens next surprised even experienced engineers, because these enormous systems can still open smoothly with a touch of a button. Hidden springs and counterbalance systems do most of the heavy lifting. Here's another surprising fact. In many homes, the garage door opens and closes more frequently than the front door. Some families operate theirs more than 1,000 times every year. That means the average system must perform reliably through countless seasons, storms, and temperature changes. Reliability isn't just a luxury. It's essential, and this is where it gets truly extraordinary. The next decade could transform garage doors once again. Engineers are developing quieter motors, advanced insulation materials, AI-powered security systems, and solar-assisted technologies. Some prototypes already communicate directly with smart homes and electric vehicles. The future may turn the humble garage door into one of the most intelligent systems attached to a house. Most people never think about this, but behind every smooth opening movement lies a chain of miners, chemists, engineers, machine operators, programmers, and inspectors working together across continents. Millions of hours of research and innovation have transformed a simple entrance into a masterpiece of engineering. And after this journey, you'll never look at a garage door the same way again. From deep iron ore mines to giant steel mills, from chemical plants to highly automated factories, you've now seen the incredible journey hidden behind something most of us barely notice. Think about this. Every smooth movement, every quiet click, and every layer of protection inside a garage door represents decades of engineering and millions of hours of human knowledge. And this is where the story comes full circle. Most people never think about this, but a garage door performs one of the hardest jobs around your home. It battles rain, dust, wind, snow, sunlight, and thousands of opening cycles while protecting vehicles, tools, and memories stored inside. What happens next surprised even experienced engineers. Something that seems ordinary from the outside turns out to be a masterpiece of material science, precision manufacturing, and human creativity. Imagine the sounds hidden inside that journey. The thunder of steel mills, the hiss of hydraulic presses, the crackling sparks of welding stations, and the quiet precision of laser scanners measuring every detail. Thousands of workers, robots, engineers, and technicians all contribute to something designed to make daily life safer and easier. But here's what nobody tells you. True engineering often hides in plain sight, and this is where it gets truly extraordinary. A product that begins as rock pulled from the earth eventually becomes a precisely balanced system capable of lifting hundreds of kilograms with remarkable ease. That transformation represents one of humanity's greatest talents, turning raw materials into machines that improve everyday life. And perhaps that's the most amazing part of all. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.